right, 7th grade math 4.2. This is greatest common factor. You're familiar with greatest common factor. We've learned how to do those before, so it'll be a review on how to do those and then again using them in real life situations. So first off, we are going to start with common factor. A common factor is, and it says a number that is a factor of two or more numbers. For example, let's say 12 and 14. What are the common factors of 12 and 14? Well, 1 can go into both of them, and 2 can go into both of them. Those are what they have in common as far as their factors. Common factors. Okay, so then GCF, greatest common factor, would be what is the greatest, for lack of a better way to say it, common factor. Okay, so let's take that 12 and 14 again. Let's do all the factors of 12. 1 and 12, 2 and 6, 3 and 4. Those are all the factors of 12. 1 and 14, 2 and 7, and I think that's it. Then this would be, these are the common factors, 1 and 2. What's the greatest common factor of 12 and 14? That would be 2. So that's greatest common factor, and we'll talk about different ways to get the greatest common factors, because sometimes it's not always best to factor them out. Sometimes that's the hard way to do it, so we'll talk about ways to do that. And the last one is relatively prime. When you are trying to find the common factor of two numbers and you can't find anything that'll go into them except 1, that means the numbers are relatively prime. So relatively prime, the GCF is 1. So let me give you an example. 5 and 7. Okay, so what are the factors of 5? 1 and 5. What are the factors of 7? 1 and 7. So what's the only thing that will go into 5 and 7 that is common? That's 1. So that's why 5 and 7 would be relatively prime. Alright, so let's do some of them. Example 1. An orchestra conductor divides 48 violinists, 24 violists, and 36 cellists into ensembles. Each ensemble has the same number of each instrument. What is the greatest number of ensembles that can be formed? How many violinists, violists, and cellists will be in each ensemble? So basically what they're asking us to do is to find the greatest common factor of 48, 24, and 36. Okay, so 48. I know 48 pretty well. 1 and 48. We're going to factor, first thing you do, you kind of work backwards. So the first thing you do is you're going to factor them. 2 and 24, 3 and 16, 4 and 12, 5 doesn't go into 48, 6 and 8. Have to kind of squeeze those in there. Sorry about that. 1 and 24, 2 and 12, 3 and 8, 4 and 6. 36, 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Okay, so their greatest common, they all have a, I didn't circle that, they all have a 12. So the greatest common factor is 12. So what that means is we can form them, the greatest number of ensembles that can be formed is 12. Well, how many times does 12 go into 48? It goes in there 4 times. So there would be 4 violinists. How many times does 12 go into 24? Twice. There would be 2 violists. I don't know how to say that. And 12 goes into 36 3 times. There would be 3 cellists in each group. So whenever you're trying to split them up into equal numbers, you want to find out what's an equal number that will go into all of them. That's where greatest common factor comes in. All right? Now, sometimes you know, it's hard to, if you leave out a factor here, that'll mess up your whole answer. So you have to be really, really careful that you're going through all of the factors and getting all of the numbers for the factors. Okay, so notice they're factoring them out. The red is all the common factors. And then they have 12 as the greatest common factor. So that one worked out really good. And it's the same thing we came up with. So find the greatest common factor of the numbers by listing the factors. Okay, so what are all the factors of 16? 1 and 16, 2 and 8, 4 times 4. Okay, 28, 1 and 28, 2 and 14, 4 and 7. Okay, so find the greatest common, okay, 1 is a common factor, 2 is a common factor, 4 is the greatest common factor. So the GCF here is 4. And let's see if, oh, we agree, 4, yep. The worst part about finding them by listing the factors up here is if you leave out a factor, that can mess up the whole problem. Okay, so let's do 60, 1 and 60, 2 and 30, 3 and 20. Does 4 go into 60? Yep, 4 and 15. 5 and 12. 6 and 10. Boy, I really didn't leave room in this, did I? Whoops, sorry. 7 doesn't, 8 doesn't, 9 doesn't, so I'm done. Okay, 96. Ooh, 1 and 96. 96 is even, so 2 goes into it. What's half of 95? 48. And if you don't know, just go over here. 2 into 96. Let's check it. Goes in there 4 times. That would be 1848. Okay. 3 goes into 96 because if you add up 9 and 6, you get 15. 32. 3 and 32. Okay, 4 into 96, it might go in there. Let's check it. This is kind of a pain, but I'd rather be sure. Ooh, look, it goes in there 24 times 4 and 24. Okay, 5 can't go into 96 because it doesn't end in 5. 6 and 96. If 2 and 3 can go into it, so can 6. So 6 and 36, 16 times. I'm running out of room. 7, I don't think 7 can go into 96. 8, well, I don't know about 8. Let's try 8. 8 into 96 goes once. 8, yeah, 8 and 12. 9 can't go into 96. 10, 11. Okay, so we have all of them. Now, I didn't do this very good. You should have them written out. 1 is a common factor. 2, 3, 4, 5 isn't. 6 is. Look, 6 is up here. 6 and 6. Is there anything higher than, oh, a 12? 12 and 12. And if I had them lined up better, it would work better. It looks like 12 is the greatest common factor. Yay! And boy, that one. Kind of tough. Look at all that work I had to do all those factors on that. Okay, let's do the next one. 14, 70, and 91. So they want me to factor 14, 70, and 91. Okay, 14 is pretty easy. 1 and 14, 2 and 7. That's easy. 70, 1 and 70, 2 and 35. 3 can't, 4 can't, 5 can. I don't know how many times 5 goes into 70. 5 and 14. 6, no. 7 and 10. Okay, 91, 1 and 91. 2 can't, 3 can't, 4. No, 5, I don't think 4 can go into 91. No. 5, no. 6, no. You know, I think it's kind of a trick. I think 7 can. Goes 13 times. 3 and... No, wait, sorry. 7 and 13. So then our greatest common factor is 7. Right there. So let's see what we got. Yep, 7. Okay, again, and it's kind of a pain, isn't it, writing out these here. Let me get erase. Let me go here, erase all this. 15, 75, and 20. So 15, 1 and 15, 3 and 5, 1 and 75, 2 can't, 3/4 makes 75 cents, 5 and I think 15, right? 20, 1 and 20, 2 and 10, 4 and 5. It's looking like 5 is our greatest common factor. Yep. All right, so sometimes, you know, there towards like 96, that was kind of hard getting all the factors of those. So one way we can do greatest common factor is use the prime factorization. So especially when you have big numbers, how would you like to write all the factors of 180 and 126? I guarantee you I would leave one of them out. So one way to do it is the prime factorization. So you take 180 and you take 126 and you do a factor tree. So 180, two numbers that make 180 would be like 18 and 10. That's pretty easy when it ends in a 0. And then you just do what we did in the last lesson. 2 times 9, stop the 2, 9 is 3 times 3, 10 is 2 times 5, and we have 2 times 2 times 3 times 3 times 5. Now we want it in expanded form. We want it written out in the greatest form, as long as it can be, in order to find the greatest common factor. 126, now I know it's even. I know 2 will go into it. Let's see, it goes into 12 63 times. 63 is 7 times 9. 9 is 3 times 3. So 2 times 3 times 3 times 7. So what I do is take those numbers and write them on top. Write the stuff on top of each other. 3 times 3 times 7. Okay, now what do they both have? They both have a 2, they both have a 3, they both have another 3. So what did both of them have? They both had a 2, they both had 1 3, and they both had another 3. So that means you just multiply what they both had. 2 times 3 is 6, times 3 is 18. So the greatest common factor of 180 and 126 is 18. And when the numbers are big, I do it this way all the time, even when the numbers are small. This is the way that I do it. So there's the prime factorization, just like we did. They didn't circle them, they just colored what was the same. No, now they circled them. And then they got the same answer we did. Okay? Now, tell whether numbers are relatively prime. So what we do here is you do the same thing. One way to do it, I don't really like to factor them. Your book factors them. Let's do this with the trees so I can show you how the trees work with this. 28 would be 4 times 7. 4 is 2 times 2. That's done, that's done, that's done. So 28 is 2 times 2 times 7. 45 is 5 times 9. 9 is 3 times 3. Done, done, done. That would be 3 times 3 times 5. Now remember in the last example we circle what's the same. Well, guess what? Nothing's the same. They don't have anything in common, but they really do, because if nothing else will go into two numbers, what always goes into two numbers? 1. So it says tell whether the numbers are relatively prime. We would say yes. Remember, numbers are relatively prime if the only thing that will go into both of them is 1. And that's what happened here. And that's them doing it by factoring it out. But I would rather do it with the trees. I think the trees are easier, as then I don't leave any factors out. Okay, let's do 15 and 51. Same idea. So 15 would be a tree of 3 times 5. Done. Sorry, my phone's ringing on me. And let's do a tree for 51. Now 51 is kind of a trick number. 3 can go into 51. I think it goes in there, let's see, 3 into 51, I think it's 17. Yep, 3 and 17. Okay, so what are these having? So 3 times 5 and 3 times 17. Well, these guys have something in common now. The GCF of these would be 3. So if we say, are they relatively prime, we would say no. Remember, they're only relatively prime if the only thing that will go into both of them is 1. And 3 can go into excuse me, into both of these. So they are not relatively prime. So no. All right, so let's do a whole bunch of them. Find the greatest common factor of the numbers using prime factorization. So prime factorization, we do our trees. 90 would be 9 times 10, 3 times 3, 2 times 5. So you do the trees also. Don't just let me do all the work. 2 times 3 times 3 times 5. Okay, 150. Love it when the numbers end in 0, because I know it'd be 15 times 10. That's 3 times 5, done with 15. That's 2 times 5, done with 10. So I'm going to write it underneath. 2 times 3 times 5 times 5. I'm getting it from right up there. What do they have in common? 2s, 3s, and 5s. So they each have 1, 2, 1, 3, and 1, 5. Multiply those out. 15 times 2 is 30. So the greatest common factor is 30. A lot of work, but again, just knowing your facts, it makes it go by really, really fast. Okay, 84. Ooh, I would not want to be writing out these in. Okay, I know 2 goes into every even number, so half of 84 is 42. 42, I know 6 times 7 is 42. That's 2 times 3, done, done, done. 2 times 2 times 3 times 7. Now 216, again 2 can go into 216. Half of 200 is 100. Half of 16 is 8, 108. Done with that one. Again 2, half of 100 is 50, that'd be 54. I know 6 times 9 is 54. 2 times 3, and 9 is 3 times 3. Okay, so let's write that out underneath here. 2 times 2 times 2 times 3 times 3 times 3. They'll have a 2, another 2, and another 3. So they have a 2 times 2 times 3. 2 times 2 is 4, times 3 is 12. So my greatest common factor is 12. It's just a matter of doing all those trees. Look at, boy, the numbers just keep getting bigger, don't they? 120, get some more room up here, would be 12 times 10. 12 is, we can use 3 times 4. 3, we're done. 4 is 2 times 2. 10 is 2 times 5. So 2 times 2 times 2 times 3 times 5. 192. I know it's even. 2 can go in. I'm not sure how many times, so I got to do a little division. 9 times that'd be 18. 12 that'd be 696. Again, 2 can go into 96. Oops, sorry. 8, 16, 848. Okay, I'm done with that one. Done with that one. 2 and 24, 2 and 12, 2 and 6. Weeshia, look at all those 2s. 2 and 3. No. No. I don't want to stop. No, continue. Sorry. I don't know how to get it back to the full screen. So you're stuck with me like this, I guess. Oh, it's not going to let me write. All right. Well, this one, I guess you're on your own to finish the guided practice. I'll let you do that. Finish up your guided practice, and if you have any questions with relatively prime, let me know. Sorry, but I don't want to lose what I've recorded. This one, the answer is 24. We would have gone through and matched up what we had, and then number 9 comes out as 1. And then when you get to the relatively prime, remember this one would be relatively prime, number 9. So give it a shot, and if you need help, please ask. I'll talk to you later.